Northrop Grumman and U.S. Air Force push Sentinel toward 2027 first flight. Northrop Grumman and the U.S. Air Force are accelerating development of the LGM-35A Sentinel intercontinental ballistic missile, with the program now targeting a first flight test in 2027 and initial operational capability in the early 2030s. The Sentinel program is intended to replace the Minuteman III, the aging ground-based leg of America's nuclear triad that has been on alert since the 1970s. The new missile must cover more than 32,000 square miles across 5 states, the same geographic footprint currently anchored by Minuteman III silos, making the scale of the replacement effort one of the most complex land-based defense programs in decades. Northrop Grumman has assembled a national industrial base of more than 500 partners and a dedicated workforce exceeding 10,000 professionals to support that mission. Over the past 5 years, Northrop Grumman has invested $13.5 billion in infrastructure and research and development for critical national security programs. Of that total, $2 billion has been directed specifically towards solid rocket motor capacity and capabilities and investment that is now paying dividends in Sentinel's ability to accelerate and scale production as the program moves from prototyping into early hardware assembly. Sarah Willoughby, Vice President and General Manager of Strategic Deterrent Systems at Northrop Grumman, pointed to the acquisition model as the engine driving results. The Sentinel program exemplifies what's possible when a bold acquisition approach meets relentless innovation, Willoughby said. Our dedicated workforce and extensive partner network are united by a common purpose to field the Sentinel weapon system with speed and scale while delivering enhanced capability to the U.S. Air Force. The acquisition strategy at the heart of the program's momentum relies on an incremental development and fielding approach, breaking the program into a series of phases that allow testing and validation to occur earlier than in traditional linear development cycles. Lessons learned are incorporated in real time rather than being deferred to later production blocks, and capability is pushed to the field faster as a result. The U.S. Air Force and Northrop Grumman credit this model, borrowed in part from practices used on the B-21 Raider stealth bomber program, for enabling the pace the Sentinel team has sustained. Like the B-21, Sentinel was designed entirely within a digital ecosystem, allowing engineers to simulate, test, and refine the missile before a single physical component was fabricated. That digital-first methodology increased collaboration speed across the distributed supplier network and reduced costly design errors that would otherwise surface only during physical testing. The approach helped compress early development timelines considerably and is now enabling the transition from virtual design to verified hardware. Northrop Grumman has assembled the first complete 3-stage Sentinel booster, verifying design integrity, manufacturing processes, and key technologies. Solid rocket motors for the first 5 planned flight tests are already in production, a significant logistics milestone for a program still years away from its first scheduled flight. Several critical test events have already been completed. 2 inter-stage separation tests validated the missile's ability to cleanly separate the spent first and second stage solid rocket motors from the rest of the vehicle during flight, a fundamental requirement for a multi-stage ballistic missile. A shroud fly-off test evaluated and validated the design of the protective cover enclosing the missile's payload section, confirming it performs as designed under flight conditions. Perhaps most significantly from a precision standpoint, the guidance and control hardware, the system responsible for steering the missile to its target, was subjected to an initial mass model sled test. That test exposed the navigation inertial measurement system hardware to flight-like environmental conditions to evaluate whether it could survive the stresses induced during an actual ICBM flight. Passing that test confirms the guidance hardware will maintain functionality through the extreme forces of launch and flight, a prerequisite for the accuracy that no-fail nuclear missions demand. Sentinel's new 3-stage booster design improves on its predecessor in several measurable ways. The solid rocket motors are constructed from composite materials that are 70% lighter than the motors used in the Minuteman III, while offering greater strength and corrosion resistance. That weight reduction translates directly into increased payload capacity and extended range, 2 attributes that expand the operational flexibility of the weapon system. With flight test hardware in production, key test milestones completed, and a structured path to initial capability in the early 2030s, the Sentinel program is moving at a pace the U.S. Air Force and Northrop Grumman say reflects the urgency of modernizing the nation's ground-based nuclear deterrent before the Minuteman III's operational life fully expires.